Okay, guys, so let me just run through how I made this ice cream simulation. So we have the mode over here. So it's just an ice cream with a stick. So you have the ice cream part and the stick part. So just have it separated, right? So the first simulation, let me just turn off this. So the first simulation, we have this uh, the liquid forming the inside part of the ice cream, right? So how I did that, so for the emitter, I just have these emitters over here, right? And this curve force. So for the simulation itself, you see I have this curve, those are the curve force. I have the curve force over here. That's what's going to run this simulation. It's going to make the particles flow like that, right? But I also use this suction force, which you can find it the particle fluid right here, the suction fluid. So right here I have a fresh Houdini scene just to show you how that suction force works. So if I just start with the flip tank, right, let's just enter. So I just have this tank over here. This is the simulation, right, and this is the initial state, and the meshing, and this for the interior, which is yeah. So from here, I can add an object. Let's say that rubber toy that I will use it to suck the water into, right? So I can just place it maybe there. Then I can select this suction fluid. As you can see, it requires me to select the suction object, right? Which is going to be this rubber toy. So I can just select suction object, place the cursor over here, press enter. Now it needs the flip object, which will be in the flip simulation. Select the flip tank, this flip object node. Your cursor over here, press enter, and there. Now we have these two nodes and the mesh node in case you want to add more of the nodes over there. So if you check the simulation, you can see it's sucking in the laboratory, right? So yes, so it made these nodes, but it also made some nodes on this laboratory right here. So this creates this volume, which is going to be used to suck the fluids in. So we can just go to the volume and maybe increase the resolution, something like that. And now if you go to the simulation, right, keep sucking the water. So you can check the parameters over here. The one that you'll be playing around with mostly on the suction force itself. So the suction strength that will dictate how fast it will suck the particles in. Right now it's going to lower it will take longer. As you can see, it will move much slower. Also, play around with this outside distance. How far will it go to suck? How far will it look for particles to pull inside? So if a larger distance pulls from a wider area, and if it's something smaller, maybe 0.5, this is pulling from a very small area, probably cannot even get much unless maybe we give it more strength. I mean, this usually requires a lot of strength. Yeah, something like that. So I'm just playing around with this the suction fluid, right? Having animated that can see we get keyframes on 321, 328 to 400. So I'm reducing the outside distance so it can tightly conform the particles to the shape of my ice cream as it continues to apply the suction force, right? So that's the only thing I'm doing right now. It's animating that. Now, when we come to meshing, we just start over here. So I have these particles. I'm just caching them. All that is nothing much of here, but over here, right? So these are the particles from the simulation. So I'm doing some retiming and the keyframe retiming. So I'm going to set it by speed and I have keyframes right here. We start with going fast and slows down and stays at like speed of 1.6. Then I ramp the speed up again. Up, yeah, like that. Yeah. So after retiming, that's when I mesh it. And also at right at the end, you can check over here as it's finally set, the simulation is finally settled, right here. It was a lot more bigger than my original ice cream shape, so I just picked it inside, just make it smaller, right? I could not scale it, I just used the normals to pick it inside to kind of squish it small. Then I use this blend node to blend between the two, between this simulation and this peak node right here. So after blending it, I have it converting this whole thing to VDB again, then convert it back to the volume to a polygon. This is because let me just show you something. So with the meshing method, you have two methods. You have the spherical and the average position. So the problem is if we have it something like that. So with the average position, you do get smooth surface, right? But the problem is you get some popping in and out of like holes in your geometry, which is really not good, especially when you have slow moving particles. Like maybe they are retained or maybe just your simulation is slow. You might have this hole popping in and out, like flickering, which is not good. So the best method they usually just use the spherical, it will be rougher, so you do need to add some filter, no dilating, eroding, smoothing. But the motion will be smooth. It won't have the flickering and the popping in and out of holes in your geometry. But the problem with this also is that if I can use a clip node, it might have these layers inside the bubbles. I mean, this mesh usually, if you are making underwater bubbles, it's like the best option, right? So, but when you don't actually need the bubbles inside, it still create these meshes inside. And if you are going to render it maybe with the material with maybe a transparent or subsurface scattering, it's not going to look good. So, not to fix that, after meshing it, I need to convert it again into a VDB, then back to a mesh, and that will get rid, and that will help to get rid of this. Okay, what's happening here? Oh, that's let me just go at the end. Yeah, yeah, okay. You can actually see those kind of like more polygons inside, right? But after meshing it again, it will get rid of anything that is inside. So now for the second simulation, which is actually the chocolate coating, right? So for the emitter, just have this simple emitter at the back with the velocity just pointing forward, right? So in the sim itself, just similar to the previous one. So you can see the splash happens, but the splash from the back, then the particles get sucked in to go around the ice cream. But this time they don't go inside because we do have a collider just to keep them on the surface, so not inside. Right? And that's what the collider does. Right? So over here, the same thing, the suction setup, we just have a suction force and an anti-gravity. And yeah, which was just searching. So the also distance is bigger, so it can, once this splash happen, it enables the suction force to pull in all these particles that are far away. That's why we have the outside distance be a little bit bigger. And of course, the suction force is larger, so it can suck it in faster. But I have this whole thing enabled, the suction force actually, enabling right after frame 120. So we do have the emission, the splash, and after frame 120, that's when the suction force starts pulling in the particles inside and just continues onwards to till the end. Just keep the particles there. Now for the fracturing, so if you just play it right here, so after the simulation, then it fractures, then everything goes back to where it was again, all the pieces go back. So that's how I did that. I just took this, all the results, the end result of all this simulation, the cream and the chocolate, right? That here at the top. So I just have them time frame at the end of each simulation. I think it's just like 120 for each one, right there. Yeah, so I go through fracturing it, and here I'm just using this grid. I just have it noised up, copied to points, just create this cutting geometry. Uh, then I use it to cut this I think it's a chocolate layer, right? The chocolate coating. So I have it sliced out over here. And for the ice cream, the interior one, I just delete I just pick one cutter, just have it cut it across like that. Yeah, and for this chocolate, I just pick this big piece at the middle and fracture it some more, just a polynomial fracture. Then I bring them all together, give them a connectivity node, then just group them. So we have the chocolate fractured and the ice cream right there, right? And then I create this the proxy geometry. We're using the convex decomposite. So I use this node to create proxy geometry, which you can see for each piece right there. Then I make the constraints for the geometry and give them just a regular, just a blue constraint that will just break instantly as soon as they get any force because they only have one force in the sim. Then if you check the wireframe, I mean, I was supposed to do this divide, the triangulate at the after fracturing them. That's why you just prevent having n-gons, which might be a problem when rendering, depending what render engine you use. Right? So let's configure it and run the simulation. So in the sim itself, we actually use we actually, if you check the simulation itself as this, it's just an explosion, right? So to make this explosive force, I use this metaball. There's actually a pop metaball force in dope node, right? So I just use this metaball to create the force, which is this metaball with the force, with this negative 1,000 force, and I have it placed at the right position, and that's what I'm reading inside here, and the rigid body bullets. So in this solver, since I created it with I think it was Houdini 17.5 back then. So when I go inside, it won't take me exactly where I'm supposed to. So I have to actually find this. It's right here, and this forces there. This something you'll be more familiar with this area, right? You have the forces input. So I am inputting those. I'm using the pop metaball for that explosive force to read it in, right there. So the force scales, I just have it already set above to be 1,000. And having it activated just on frame 3, right? So, okay, once you get to frame 3, that's when it activates. So I just have a pop drag for all the pieces. Then for the bigger pieces, I just have it slow down a bit more. So anything with a mass more than 1,000, so it will slow down a bit more. And also they were spinning around so much, so I had this pop spin drag the spin, and that's it. So you can go back outside. So this is the simulation of the explosion. So after that, just take the points, the simulation points. Again, just retiming them with keyframes again. Just have them control the speed ramp. So have them starting fast, then slow down. That's it. Just slow down and then stop. Right? So have this time shift to reverse the animation. So you can see it starts at the end and goes back. And here I'm just using the flip node, just going from 148 to 48 to 1. So just like inverse of what's happening. And this time retime node just to shift the whole animation to start at frame 48. Right, frame 48. Let's switch it over there. So I use these transform pieces to control our geometry, right? That's coming in from here, or then from just after factoring and everything, right? So I just have it unpacked, so you can have it full. Give it a rest node for the materials and stuff. So I also use this node called connect RB connected faces. So this one works together with this RB disconnect faces. And what it helps is, if you can check over here on the explosion node, which check the estimation just after it explodes. So before the pieces come apart in the simulation, to go frame by frame, you see the inside faces are actually deleted, but the moment everything breaks apart, the inside faces come actually appear again right there. So this is useful if you're making something that maybe fracturing a glass. You don't want it before the glass actually breaks. To have the inside faces actually visible. So you can use two nodes to delete the inside faces before the fracture before the object actually breaks the simulation. Yeah. So have that time shifted at the right time. Yeah. And that's it.